So these learning strategies, I'll talk about them one by one, give a bunch of examples. So these are spaced repetition. Then you have interleaving, retrieval practice, elaboration, and you have concrete examples. And finally, dual coding. Now, these are not exhaustive. There are other strategies. You can find them in other papers, but these are the 6 strategies that were discussed in the paper that I'll share with you. And you can start with this, right? And let's compare this versus what's typically done by students that are not effective. So let's go straight to the to number one, spaced repetition. The idea here is this is when you study something and then you spend time studying that, but you have to take breaks. So take a break. It could be a couple of hours, 2 days, 2 months, and then go back to the material. Now contrast this with what students typically do, like in school, which is what they call mass practice. So this is when you cram for an exam. So let's say you have an exam tomorrow, and then you cram everything. You try to learn everything for that exam. The it so according to research, this could lead to good performance in the exam. However, this does not support long-term storage of that information. So maybe you will perform great by cramming for that exam. You will pass, but 6 months later, you you will have forgotten about that. And essentially that makes learning pointless, right? You have to be able to store whatever you learn in your long-term memory for it to be useful. And to facilitate that, you have to do spaced repetition. So you study, let's say, something for 1 hour and then take a break. Maybe an hour or maybe one day, right? And then go back to that material, study it again, and this actually helps you with consolidation of that information into your long-term memory. Now, there are a bunch of hypotheses why this is the case. So one is the brain actually needs hours to days to form new neural connections. It's not like when you study something, it's not like you suddenly have new connections, because neurons are biological entities, they're cells, and they take time to connect with each other. So when you learn something, they have to create new neural connections. And this takes time, right? Like you can imagine cells move kind of slowly. And so you have to give it time, maybe hours, days, and things like that, for things to consolidate and then go back to the material. Now, why would you want to go back to the material? You want to go back to the material because you will have forgotten a lot of things. So in that period of time, when you were resting, there would be like new connections happening, but then some of the connections will not form, and then you will forget like 50% of the material. And so you have to keep repeating, you have to keep studying in a spaced way. This is in contrast to if you're trying to remember something, you study it for like 6 hours nonstop, right? Let's say, oh, I want to remember this, I'll study. That's not effective at all, right? What will happen is you're gonna forget about that. So what you do is instead of studying something for 6 hours straight, study it for 1 hour, then maybe wait like tomorrow, study it again for an hour, and then maybe wait for a week and study it again for 1 hour. So that's what spaced repetition is about. Now, there's a question of how long do you wait? And this is still a topic for further research, but some of the research, okay, so it's not like it's conclusive, but they found that if you want to store something in long term, like longer term memory, like you want to remember something for years, then it's best if you keep going back to that even several months after. So in fact, when you're doing like, let's say you're programming, right? You're actually doing spaced repetition as part of your job. Because for example, maybe you need to learn a new framework, and then you read about it. The first time you read it, maybe you learn 25% of it and then forget 75%. And then you're gonna say, okay, I forgot about it. I'll need to go back to that uh, documentation, read it again, right? And so it's like hands-on um, coding, and like working towards a project and trying to understand latest frameworks and latest ideas, latest tools naturally enforces spaced repetition. So that's the first one. So I'll just go through this really quickly because we just allot 30 minutes for this, and it's already 1:25. But that's spaced repetition. But like we can talk about this later. Now, interleaving is actually um it's like a supercharged version of spaced repetition. Why? So while spaced repetition looks like this, let's say you're writing study A, so topic A, and then you space it out, right? So you take breaks. Now interleaving looks like this. So it's still a form of spaced repetition relative to a topic. So relative to A, it is spaced repetition. However, you're actually maximizing that break by studying things in between. So you study B, but you also do spaced repetition, and then you study C. So it's like a much more supercharged version of spaced repetition. So how can you put this into practice? So for example, you're studying uh like I don't know, JavaScript, like a JavaScript framework or something. I don't know. Let's say that's A, right? Then you study Python. Okay, so you're studying that A 1 hour for 1 hour. Then after that, maybe you take a break for like 5 minutes. Then you study Python. And then you're gonna say, okay, that's kind of confusing. Like, why would I study JavaScript and then I'll study Python later? And then I'll study uh maybe you study Java. I don't know, like I don't know, whatever you want to study. That's C, and then you study something else. It does sound confusing, right? It does sound like it will confuse you. And actually, this is the reason a lot of students and teachers hate interleaving. So according to research, students and teachers prefer not to do interleaving because it feels confusing, right? But according to research, it's just a feeling. So you feel you're confused, but actually you're learning more. So that's the paradox with it, right? Uh, Mass practice, on the other hand, feel like you're learning a lot. Within that 6 hour period, you're studying something. So imagine it's like a workshop, 6 hour workshop. Oh, I learned a lot. You feel like you learned a lot. So that's why a lot of people like that kind of setup. But after 6 months, you forget about it. Meanwhile, spaced repetition and its supercharged cousin, interleaving, is so difficult and confusing that it feels like you're not learning anything, right? It feels like it's a very slow kind of learning. Like, why do you do this? Why do you study A, then B, B, B? Isn't this gonna be like much more productive? It turns out no, like paradoxically. So cognitive research tells us it's better to interleave because first it facilitates spaced repetition, which I mentioned before, right? Like why it works, but it's like a much more effective version of it. All right, so I'm pretty sure like you may have questions or things to add, but let's just go through all of these quickly. Now, retrieval practice works with spaced repetition and interleaving, so they work hand in hand. What does it mean? It means that instead of reading something and rereading it, right? Rereading or rewatching, right? These don't work. So apparently a lot of students have this um, misconception about familiarity. Like, okay, if I just read a book 10 times, then I will remember it. It turns out there's actually a much more effective way to do it, which is use retrieval practice. And it works well with interleaving and space repetition. So what happens is, for example, you study A, you take a break, right? Maybe you study B, C, D. Now, once you go to A, once you go back to A, you try to recall what exactly did I learn, right? This is very difficult. It feels like it takes a lot of effort. And in fact, according to cognitive science, this is exactly the reason it is highly effective. So effort leads to learning. If learning is easy, you're not learning a lot. So that's very clear from cognitive science research. Okay, let's go to number 4, elaboration. Now, elaboration is okay. So again, needless to say, these things go hand in hand. So they support each other. So elaboration is like if you're familiar with the Feynman technique, which is if you learn something, try to explain it to a 5-year-old. And that uh, that exercise of trying to explain it helps with understanding, helps with identifying gaps in your understanding. If you cannot explain it that well, then that's a gap. And now you've identified, okay, I don't get it, so I need to study that and try to understand that gap more. And elaboration also helps with retrieval practice, essentially, because when you're elaborating something, when you're trying to explain it in your own words, so that's what elaboration is about, specifically like why and how. So why is it like that, how is it like that? um, if you do that, you're trying to represent that information as your own. So you're not just like restating what you've already learned, like, or what you've read word per word, but you want to represent that in your mind as some sort of concept that's your own, and your own interpretation that is connected to your prior knowledge. So you have already pre-existing knowledge, and then you try to relate that new information with the other pre-existing knowledge, like, oh, this sounds exactly like this, or this sounds like that, right? So when you're studying a new framework, oh, this looks familiar. This is like framework X that I've studied like a few months back. So by elaborating, you make it your own, and it improves storage in your long-term memory. It improves understanding. It helps you identify gaps. All right, so that's elaboration. Now, number 5 is concrete examples. And it's just a way to help with understanding, because there are cases when you're trying to understand something that's really abstract, and it's just hard to grasp something that's abstract. So what you want to do is you want to give, or you want to try to come up with examples of what they mean. So this helps a lot with, for example, things like math. Uh, right? Things like math. So for example, a squared plus b squared equals c squared. And it's like, okay, this is like so abstract. Like, what does that even mean, right? So what you do is you give yourself like examples, right? So let's say let's say if A is 1, B is 2. So you're gonna say, okay, what is A squared? What is B squared? Right? And then you're gonna say, okay, let me calculate that. So this is 1, this is 4. So C squared tells us like it's 5, right? And then you relate this to a triangle, right? So this abstract concept, you relate it to something that's more understandable, right? So it's actually represents a triangle. And then you try to, give yourself a bunch of examples like, maybe these are variables, but what if I plug in actual numbers? So those kinds of things. And you try to relate it with your everyday experience, right? Or when you're trying to learn something, try to relate it with, something maybe you've encountered before, or essentially something you can relate to. And finally, dual coding. Dual coding is when you combine words with visuals. So words plus visuals. So when you're learning something, you try to relate some visual thing with whatever it is. So for example, if you're learning code, so maybe those could be the words, right? Then you imagine like some visual representation of the code. Now, the act of trying to visualize something, right? You can draw it, right? So for example, you're trying to understand the connections between databases, right? So you can like visualize. So this is like DB1 and then like it's connected to something, right? Um, that's one way to visualize it. Now, the act of combining like words with visuals, it helps with understanding and helps with representing concepts in a way that is in a way more embedded in your what you could call a knowledge network, right? So what is a knowledge network? Or so or it's like a database, right? But really your knowledge is not just a database of like rows and columns, but it's actually like a web of concepts where there are relationships among all these different concepts. And if you try to represent things in visuals and words, then you can embed these things more tightly with the rest of your knowledge network. And it actually helps you with like um, forming new connections. Because if you visualize something, you may find new insight, right? That, okay, this looks like this other thing that I know. So yeah, just a quick run through of these different strategies. Now, like you can start doing this, right? If like later, right? You can like make it into a habit. And the thing is, it's gonna be really hard, right? If you're used to just reading something and then getting it over with, or listening to a lecture and be done with it, this is much harder. But that's actually the reason it's much more effective. Also, it feels slower, right? This feels slower. This feels harder, tiring. It's much more tiring to do these things, but you will reap the benefits because if you do these things, you can um, you can remember them better, right? So you can remember them better, you can understand them better, and in fact, research tells us that you can transfer these knowledge into other domains or other tasks much better, right? So it's not just, let's say you're studying programming or something, it's not just isolated in that particular field. Whatever you study can spill over to other things that you're doing. So I don't know, like maybe you're doing other things, right? I don't know what you're doing aside from coding, right? But the fact that you're trying to understand better and then recall better the information in, let's say, programming, uh, your brain can actually use those information for other things. So that's what you call like transfer learning, right? So yeah,